Hello, and a big welcome back to all my subscribers. And if you're not a subscriber, why not? Right, today I'll just give you an update, and possibly, most likely the last update on my attempt to build an operating system within an emulator. So, this project was basically about creating an operating system with an M68K based emulator, so that I could start to pre-code things before I get the hardware developed done on my 68K board. But anyway, the idea was that I would boot from a hard disk image, a file, or a floppy disk in a way that sort of mirrored the real hardware, or some real hardware. And so my goal was to create a realistic boot process, load the kernel from the file system, and interact with the storage devices. But I've run into many issues around the emulator. So I've tested many different emulators, and there's just no available emulator that supports this approach without significant modifications or some sort of proprietary firmware dependency. So, for example, a Mac ROM or whatever. So, basically, I tested in the main QEMU. Let me just show you. I tried all sorts. I mean, this is the commands with the various machines. Nextcube, and I basically tried the lot. I was getting fairly successful with Q800, which is the Mac version. So yeah, and this is just one sort of page of all of the stuff that I was trying to do to get this thing to work. So what I tried was I was trying the QEMU M68K, and I was attempting to get it to load this with different machines, but to load a hard disk. So most of the time these failed because they don't have any disk controller. So there's no IDE, there's no SCSI, there's no floppy disk controller. The Q800 machine does have a SCSI controller, but it requires a Macintosh ROM to function, or at least as near as I could tell. And so it's not compatible with a sort of a custom OS and a custom bootloader. Now, so the manual scans of the MMIO addresses confirmed there was no disk controller exposed on any of the non-Mac machines. So even with a drive attached, QEM doesn't have any way for the CPU to access it. So in conclusion, I couldn't use QEM2 because I had no way to either create the firmware or have a disk controller emulation by default. So I tried the Atari, which is an Atari emulator, and it emulates various Atari and Falcom models, and they use the 68K and later processors. But the problem with these is the same issue, really. There's no IDE or ACSI controllers. So disk-based booting wasn't really working on this. And Atari systems rely on TOS firmware to initialize the disk controller, and I don't have that and can't use it. So that doesn't work. And you can't just simply replace it with a custom bootloader. So that was a non-starter. UAE is an Amiga emulator, and it uses M68K CPUs. And it does have disk support, and I tested it, but it uses Kickstart ROMs to initialize the IDE and SCSI devices, and without the Kickstart, the disks don't respond, and the raw access to the disk controller isn't possible. So this doesn't allow direct low-level control of hardware without Kickstart, and so I couldn't write a custom bootloader, and so that one was a write-off. And then there's ARNEM. I don't know how you actually say this, but it's capital AR, capital ANYM, capital M. So in theory, this does the Atari Falcon hardware, which also is the 68K plus CPUs. And just like the other, it needed TOS to initialize disk access, and so MMU support is incomplete and couldn't do a custom OS, so that was a write-off. Then there's the Macintosh emulator, which emulates classic Macintoshes, and it also supports SCSI disk controllers like the QEMU, but again relies on Mac ROM firmware for hardware initialization, and without a valid Mac ROM, system doesn't boot, yada yada yada, doesn't work. So I flipped over to MAME, multi-system emulator. So MAME/MES emulates a whole variety of computers and arcade machines, and some of those are M68K based. So I tried looking for a bootable M68K machine with disk support, and I attempted to load a custom bootloader on an emulated system. And while it does support arcade-based systems, it generally tends to lack disk controllers again. And the few computers that do support disk require proprietary firmware. And so just another problem is it's not really designed for raw OS development, so it just lacks hardware bootable disk things for making it, a custom thing. So basically my conclusion was I can't find an emulator which is suitable. So after testing all of the emulators I could find, none of them gave me a working solution for a disk-based booting. So there's no disk controller emulation, there's firmware dependencies, there's no BIOS-like booting. So some of these systems don't provide firmware independent disk initialization, no low-level disk access, etc., etc. So the options I've got are basically create a RAM disk and use initRD on the QEMU, which would allow me file access and doesn't require a disk controller, but it isn't actually emulating the hardware setup that I wanted. Or I could create an MMIO-based virtual disk, kind of the same problem. Or I could go away and download all the source code for QEMU and try and take the SCSI disk controller that's in the Q800 machine and try and put that into the virtual machine or one of the others, so that they do support a SCSI disk, which would allow me to mount my disk image and then look for the kernel within the boot sector of the hard drive. But that seems a lot of work. So, ironically, I went to ChatGPT to try and find other solutions or possible answers, or has somebody else done this before? And one of its suggestions was use actual hardware. Thank you very much. That was the whole purpose of trying to use an emulator, so that I wasn't using actual hardware. Anyway, it turns out I'm probably going to wind up using the actual hardware when I write my operating system. And I can't find a workaround for the emulator issue. I mean, I learned a lot about emulators, and I did learn a lot about the booting and kernel and initialization and boot sectors and hard drives, and a significant amount of information. Actually, let me just... some of the things that I was working on, a lot of it was the disk I/O and the SCSI and loading kernels and things. But yeah, a good chunk of this was all about learning how to do... why is it not working? Finding the boot sector on a ext2 disk. So a lot of it was just trying to find the super block, reading the super block, getting the inode structure and then traversing the root nodes to try and work out where the kernel actually was. Now, this worked. I was using it initially. Let me just... yeah, so I was using this initially to just read a file, because this file is a file system. It is just a raw file image that was going to be loaded into the QEMU. But I did learn quite a bit about reading inode tables, reading the file structure, and then getting the inodes, extracting the information, traversing the directory, all of that. So it wasn't a complete waste of time, is what I'm saying. I did learn a significant amount about the ext2 file system whilst doing all of this. So it wasn't a fruitless exercise. It was very good, very interesting. When I come to implement this on the actual hardware, this is going to be very useful to know. So it wasn't, any learning is good. It wasn't a complete waste of time. I couldn't do what I wanted to do, which was start writing the OS, but I did learn a significant amount about file systems, file system structure, how to read it, how to traverse directories, all that sort of good stuff. So anyway, what I'm saying is basically any opportunity to learn is a good opportunity. So it wasn't a waste of time. I'm glad I did it, but I'm basically going to stop here as far as the emulators go. I don't really see any point carrying forward with this. Don't really see a point in doing a RAM disk, so I'm just going to sort of park the operating system piece here, and I will develop the operating system directly on the hardware once I get the stupid hardware working. Anyway, that's it from me. If you like these sort of things, please like and subscribe to the videos. And also, if you like the sort of programming, assembly language stuff, please watch all the rest of the content on my channel. I do have sort of making a CPU long ago, like a Ben Eater job. I wrote a compiler for that, an assembler for that. I also wrote my own emulated CPU, and I wrote an assembler for that. So all of that was in Python. So in addition to writing code in sort of RISC-V assembly and all that sort of stuff. Anyway, have a look at all of my other stuff on the channel, and if you like it, please like and subscribe. And I also have a significant amount of information regarding human languages, other languages, learning French and Italian and whatever else. So if you like this sort of stuff, I also do that. Right, thank you very much again, and I will see you soon. Bye.